Hi, good evening, everyone.
Good evening.
Okay, so this is your qualifier revision session for week 9 to 12. Yeah, my screen is visible now. Is my screen visible to you?
Yes.
Okay, so here I have some questions from week 9 to 12. Okay, that we will solve together. So first, you guys will give it a try to these questions. Okay, and then I will show you how to solve these questions. Okay, so the very first question is from week 9. So the question is range of a random variable x um, is the set of all possible values that x can take. Let a random variable y be defined as the number of tosses until first head comes on tossing a coin. Then what will be the range of y? Like answer is given on the screen, but you should think why this answer is correct and how would you solve this question? What is your approach? Yeah, anyone would like to explain this question? Yes, anyone?
Yeah, so basically the range of uh, random variable x is it is given to be the set of all the possible values that x can take. So if
Hmm.
we are tossing a coin, we
Hmm.
could have like for like uh, one head and then two or three, four, like that. So that will be the range of the variable y.
So here, what is your random variable y? So y is defined as the number of tosses until the first head comes,
Right,
right? So maybe on the first toss we get a head, or maybe on the second toss, or maybe on the third, and so on, right? So the range of y will be starting from one and going up to infinity, right? So option number C, that one, two, three, and so on will be correct, right?
right.
Any doubt in this question?
So
Okay,
it is the
so
number of tosses, not number of heads or tails.
yeah, so y is defined as the number of tosses until the first head comes, right? So maybe you toss your coin first for the first time and you get a head, okay? Then it will be one, okay? Or maybe on the second toss you get a head, or maybe on the third toss, okay? So the range of y will be like one, two, three, four, up to so on,
Right.
okay?
Yeah.
Yeah. So question number 2 is a machine measures length of synthetic fabrics and associated imperfections in the fabric. So let x be the error in the measurement of length and y be the number of imperfections per 10 meter. Then you have to choose the correct option. So here you have to decide whether x and y are discrete variable or continuous variable. Okay, so first
Why
of
will
all, what is a discrete variable and what is a continuous variable?
why will be a discrete variable?
Okay, and x.
X is the error in the measurement of length. So
Hmm.
X can take any value.
True value.
Yes.
It need not be 0, 1, 2 or something like that. So it can be
Yes.
anything.
It can
Hmm.
be
X is a continuous
number as well as, yeah, it can be
one.
Hmm.
continuous as well as discrete also.
Yeah. So here x will be continuous variable, not random, continuous variable, and y will be discrete variable.
Discrete.
Okay, so like what is discrete and continuous variable? Anyone would like to explain?
Discrete is basically on the number line, it is countable basically, even if it is infinite.
Hmm.
Whereas
Yes,
count
discrete and floats are
continuous, like, even the decimals are a part of it. So most of the times it becomes non-countable in the number line.
Yes, so discrete variable takes discrete or distinct values on the real line, right? And it are like these variables are countable, right? And continuous variable takes value in an interval, and it can take any value in this interval, right? So these type of variables are measurable. So we measure these kind of variable, and discrete variable are countable, right? Any
Correct.
confusion in this?
Yeah, that's yeah.
Yeah. Okay, so this is the difference between the discrete and continuous variable. Okay, so here what is x? Like it is telling you y is what? Number of imperfections per 10 meter. So it would be like zero imperfections or one imperfection or two or three and so on, right? In this way. So y is taking distinct values on the real line, right? That we can count. So y will be discrete variable. Okay, and x is what? X is the error in the measurement of length. Okay, so it will be taking any value like 2.2 centimeter or 1 meter or whatever it is. Okay, so it will be taking values in the interval. It can take any value. Okay, that we can measure but not count. So x will be continuous variable. Okay, so option A and D are correct here. Now question number 3. So question number 3 is, which of the following is are discrete random variables? So option A is length of phone call.
Continuous.
So what will be option number A?
Continuous. Continuous length of phone
Continuous.
call.
Continuous. Okay. Option B,
Discrete.
number of customer visiting every hour in the shop. It will be discrete.
Discrete.
So option B should be correct. Now option C, amount of milk produced yearly by a particular cow.
Uh,
How we like describe amount of milk? Try to focus on this thing.
We have to measure, so it is
yeah.
Continuous.
So total
Can
amount
you?
of milk basically produced by the average of those particular milk. So continuous it should be.
Yeah, so it will be continuous amount of milk, right? It will be in liters. Okay,
Right.
so that will be like measurable, not countable. Okay, and
Yeah.
it can take any value. So it will be continuous. Sorry, I should not take it. Okay, then option number D is number of accident taking place every hour on NH10.
Discrete.
So it
Discrete.
will be week, right? Then travel time for your home to office.
This is continuous.
Continuous.
This will be
Continuous.
continuous, right?
Yeah.
Okay. So option number B and D are correct here. So the next question is, a random variable takes the values 1, 2, 3, 4, and 5. So the table 8.5.1 gives the PMF, like the probability of x at point x. Then find the probability of x is equal to 5. Okay, so this is the probability mass function given to us for random variable x. We have to find probability at 0.5. Okay, try to solve this question.
here we will have to equate now, like t plus t by 2 plus 4t square plus t by 2 is
Yes.
equal to.
Okay. So what are the properties for a PMF?
Sum of all the possible probability that those points has to be 1 and greater than 0.
Yeah.
Px has to
So there are two properties for a PMF. Like the probabilities should be greater than or equal to 0, right? Okay, and the second property is that summation of all the probabilities that should be equal to 1, right? So here first what we have to do, we will find out the value of t. Okay, because probability at point 5 is 3t by 2. So first of all, we have to find the value of t by using the second property. Okay, then you just have to put the value of t in this case, in this, and you will get the value of probability at point 5. Okay, now tell me what will be the value of t here.
P of
We'll have to solve the equation, which will be like 8t square plus 3t plus 6t equals to 0. Right?
3 by 4. 3 by 4 will be the answer. B.
Okay, so what we have to do, we have to use the second property first, okay, which is summation of all the probabilities at the points which x is taking here should be equal to 1. Okay, which means 0 plus t plus t by 2 plus 4t square plus 3t by 2. Okay, so this summation should be equal to 1, right?
So
Now from
answer is
here,
1 4,
we
1
will
by
find
4.
the value of t. Okay, so it will be 4t square, okay, plus 3t equal to 1, right? Okay, so from here you have to solve this quadratic equation, which is this. So I can write it like this also. Okay, so from here the value of t will be equal to minus 1 and 1 by 4, right? So these are the value of t. Now should we consider all the two values or any one of the values?
Positive one. Positive will have to consider.
So
One.
yes, so t equals to minus 1 we cannot take, because in that case the probability is that will be negative. So t equals to minus 1 is not possible. So the value of t will be equal to 1 by 4 here. Okay, now we have to find probability at point 5, which is equal to 3t by 2, right? Here you can see it. Okay, now just put the value of t, so 3 by 2 into 1 by 4. Okay, so it will be 3 by 8. Option number C will be correct. Now is it clear? Any
Yes.
doubt in this question?
No.
Yes or no?
No, no, thank you.
No doubt. No doubt.
Okay. Now the next question is cumulative distribution function of the number of defective items in the shipment of every 10 item is given as follows. Okay, so the CDF is given to us. Then find the probability that there are 3 defective items in the shipment of 10 items. Okay, try to solve it.
Is it 0.09?
Yeah, answer is 0.09. Okay, so let's first understand what is cumulative distribution function. Anyone? What is CDF?
So basically, it acts like the step function. So what happens basically, the moment we keep on drilling down all the probabilities at various different levels. So basically, we keep on adding it. So for example, P1 will be P0 plus P1, then P2 will be P0 plus P1 plus P2, and so on. So in that case, we get the basically the step thing in this thing. So this is how I believe we do the
Uh,
distribution
yeah,
function.
it's correct. So suppose this is your line. Okay, this is some value. Suppose this is A. So what cumulative distribution function does, it accumulates the probabilities up to that point. Okay. And what is the formula for CDF if you have to find it for point A? Okay. So that is equal to probability that X is less than or equal to A, right? So what it does, it accumulates the probabilities up to that point. Okay. So you can use this formula and you can find the value of probability that there are 3 defective items in the shipment of 10 items. So here what we have to find probability that X is equal to 3, right? We have to find this thing, right?
Yes.
Okay. So how can I find this thing? By using the CDF.
So basically, we can see the step change. Now, say
Hmm.
for example, at definitely at P of 0 will be equal to 0, the first one, when X is less than 0. Then next, when we will go to P, when in case of 0 less than equal to X less than 1.
Hmm.
So in that value, it will be, the value will be basically start from 0.41.
Yeah.
So
So it
in the
is,
next, yeah,
yeah.
okay.
So the graph of CDF in case of discrete random variable, it is a step function, right? Okay, like this. Okay, and this jump is the probability at that particular point, right? So by using that, by using the graph also, you can find the probability at some point. Okay, also you can use the formula of CDF. So I can write it like this also, that probability X is less than or equal to 3 minus probability X is less than or equal to 2. Okay, so suppose this is your line. Okay, and this is 2 and this is 3. Okay, this is 0 and up to suppose 10. Okay, suppose so this is 2 and 3. So what this says to you, like probability up to this point and probability X is less than or equal to 2, so this will be like this area. Okay, and we know that it is a discrete variable, so in between 2 and 3 there is no point, right? So if I subtract CDF, which is what? CDF at point 3, okay, minus CDF at point 2. So that will give us the probability at point 3. Do you agree with this? Okay, so
Yes.
like from the figure you can see, uh, we are removing this part, like up to this part is removed. So what is left? This thing. Okay, like probability at point 3 only, because there is no point in between 2 and 3. This is a discrete random variable. Okay, in continuous we cannot write it like this, but in discrete we can write it like this. Okay, so CDF at point 3 is what? 1. Okay, when X is equal to 3, then CDF at that point is 1. So this value is 1 minus F2. So CDF at point 2, when X is equal to 2, this is 0.91. So 0.91. Okay, so that will be equal to 0.09. Right? So in this way, by using the CDF, you can find the probability mass function, or you can say probability at some point. Okay, any doubt, any question regarding to this question? Is it clear to everyone?
Yes.
Yes.
Yes, yes.
Okay. And by using, by looking at this step also, this jump also, you can see the probability at point 3 you can find. Okay. So that step will be 0.09, that jump between these two steps. Okay. Now the next question is from week 10. So if the expectation of uniform distribution whose probability mass function is given in this table, then the value of n is. Okay, so we have to find the value of n in this question.
Is it 19? N equal to?
Yes, the value of n is equal to 19 here. Okay, so first of all, what is uniform distribution? What do you understand by it? If it is a discrete random variable.
Uniform distribution is basically the outcomes are the probability of the outcomes are equally likely.
Yeah, so in that case, like it is uniformly distributed, which means that all the values of x that x can take here are equally likely to occur. So all the points have equal probability of being occurred, right? So here you can see that n points are there, 1, 2, 3 up to n. The values of x is this. Okay, so the probability for each point is 1 by n, right? So this is our uniform distribution. Now, what is given in this question? If the expectation of uniform distribution whose probability mass function is given is 10. Okay, so the expectation of x in this case is given to 10 here. Then we have to find the value of n. Now, what is the expectation? How we find expectation?
The
By
sum of basically the
taking sum.
yeah, x into px basically of all the observations.
Yeah. So the formula of expectation is like this: summation of x into probability that x random variable capital X taking value small x. Okay, like the point and the corresponding probability. Okay, so in this way we find out the expectation. Okay, so here you can see that x is taking values 1, 2, 3 up to n, and the probabilities are 1 by n. Okay, so it will be 1 into 1 by n plus 2 into 1 by n plus 3 into 1 by n up to n into 1 by n, which is equal to 10. Okay, so 1 by n I can take common here, so it will be 1 plus 2 plus 3 up to n. Okay, and what will be this summation? Sum of n natural numbers. So this is equal to n plus 1 by 2, right?
Yes.
If you remember it. So n will be cancelled out. So n plus 1 is equal to 20. Okay, so n will be equal to 20 minus 1, which is equal to 19, right? Okay, so here we can see that x will be taking values 1, 2 up to 19. Okay, and this probability will be equal to 1 by 19 for each outcome, right? Is it clear?
Yeah,
Yes,
yeah.
ma'am.
Okay. Now the next question is, which of the following statement are true? Now check which one will be correct.
Madam, is it A, B, D?
A, B, and D.
D.
Okay.
A, B,
So
D.
okay. So like what is given to us? Option A is expectation of AX plus B. So if you remember the formula, so A is this is equal to A times expectation of A, expectation of X plus B. Okay. So like if you take expectation of any constant, okay, here A and B are constant. Okay. So if you take the expectation of any constant, so that should be equal to that constant only, right?
Right.
Suppose you have some
Yes.
values like 10, 10, 10, 10. And if you take average of these values, that should be equal to 10 only, right? Because these are constant, right? So in that way, you can understand that expectation of any constant is always equal to that constant only. So expectation of B will be equal to B only. Okay. And how you can understand this thing, that expectation of AX is equal to A times expectation of X. Okay. So expectation is nothing but the long run average, right? So suppose you are doing an experiment for a large number of times. So what expectation tells you? So it is the average of the outcomes that you get for all these large number of outcomes, large number of trials, right? So suppose you have some data, like suppose x1, x2 up to xn. Okay. And what you are doing here, you are multiplying by a constant to each value, a times x1, a times x2, okay, and up to a times xn. Okay. So you find average of these values. Data set first, this is suppose data set second. So suppose this is x bar. Okay. Now if you try to calculate the mean or the average for the second data set, that will be equal to a times x bar. So what is mean or arithmetic mean or average? So what it does, it is summation of all the values divided by the number of observations, right? Is it correct or not?
Yeah, right.
Yes, ma'am.
Okay. So mean is
Yes.
equal to this. Okay. Now what we are doing, we are multiplying each data point by some constant. Okay. So in that case, so suppose mean is equal to summation of all the observations divided by n. Okay. Now in each data set, you have multiplied by some constant. Okay. So it will be a times xi, right? So may I write it like this also?
Yes.
Okay. Now since a is a constant, so I can write it out of the summation, right? So it will be a times x bar. If I represent it by x bar, so this is the mean for data set 1, mean of first, and this is for second. Okay, so you can see in that way. So expectation will be like a times expectation of x. Okay, so in that way the expectation is affected when you add a constant or multiply a constant to your random variable. So option number A will be correct, right? Now option number B is expectation of ax plus b whole square. Expectation of ax plus b whole square, right? This we have to find. So if I open this square, it will be a square x square plus b square per plus 2 times a, b, and into x, right?
Yes.
So if I write it, it will be a square expectation of x square plus expectation of b square, right? And expectation of b square will be what?
D square. D square.
B square only. Okay. So I can directly write it b square. Okay. Plus, if I take expectation to this term, so it will be 2ab expectation of x, right? Because 2ab is constant. Is it correct? Do you understand this thing?
Yes.
Yes,
Any
yes.
doubt to anyone? So now we have to check which option will be correct. Okay, so 8 square expectation of x square, that is one term. Okay, another is b square plus b square. Okay, plus b square, and the third is 2ab expectation of x. So option number B will also be correct. Okay, now for the C and D, we have to check it for negative. Okay, so expectation of ax minus b whole square. So it will be equal to expectation of a square x square plus b square minus times 2abx, right? So that will be a square expectation of x square plus b square minus 2ab expectation of x, right? So here you can see that option number D will be correct, right? So options A, B, and D are correct. C is incorrect. Now is it clear?
Yeah.
Okay. Now the question number 8. The variance of number of tickets sold in a day in an opera theater is 25. If for each ticket sold the profit obtained is 25 rupee, then what is the variance of profit obtained in a day in rupees square? Okay, so try to solve this question also.
Is it 6.25?
The answer is this.
What was the answer again? Can you show?
Yes. Anyone who got the correct answer? Okay, so for as we
Maybe
study this, hmm,
625 whole square by 25, right?
okay, let's solve this question. So as you see, this is one of the property of expectation, right? So similarly, we have for variance also. So suppose you have a random variable x, okay? So like this is your variance of x. Now, if you have variance, if you have a random variable ax, if you have to find the variance of ax, what will be? It will be equal to what? So if I
Sir,
say,
let's go back.
Wait.
so if I find expectation of ax, it is equal to a times expectation of x. Okay, but if I have to find the variance of the same thing, variance of ax, so that will be equal to a square times variance of x, right? So this is a property for variance. Okay, and if you have to find the variance of any constant, suppose if we have variance of x plus b, so that will be equal to variance of x only, because if I write it variance of b, so the variance of any constant will be equal to 0, right? Because it is a constant, it is not changing. So there is no variation in the constant. So variance for any constant is always equal to 0. Okay. So if I add any constant to our variable, the variance will not be affected. Okay. So if I'm adding any constant to my random variable, okay, in that case, variance will not change. Variance will be same. But if I am multiplying any constant to the random variable, okay, so in that case, how it affects? So variance of ax will be a square times variance of x. Okay, so this property we have to use here. Now, what is the question? Question is the variance of number of tickets sold in a day in an opera theater is 25. Okay, so this variance is given to us. So suppose if I have a random variable x, suppose I have a random variable x, which is representing number of tickets sold in a day in an opera theater. Okay, which is number of tickets, number of tickets sold in a day in an opera theater. Okay. Now variance of x is given to us, right? Which is 25. Is it clear till this point?
Yes.
Okay. Now, now next is if for each ticket sold, the profit obtained is 25 rupees. then we have to find the variance of the profit obtained in a day. So suppose we have another random variable y, okay, which represents profit obtained in a day. Okay, so random variable y represents profit obtained in a day, right? Now what we have to find? We have to find the variance of this random variable y, right? We have to find variance of y, right? Y is what? Y is representing the profit obtained in one day in rupees square. So we have to find variance of y here. Now we have to see how y and x are related to each other.
Y is 25 into X.
Yes, so y will be equal to
625.
25 into x, right? So you can see this thing like x is what? X is number of tickets sold in a day. Okay, so x is representing number of tickets, okay, sold in one day, and 25 is what? For each ticket sold, the profit. Okay, so for each ticket, for one ticket, the profit is 25. So for x number of tickets, the profit will be 25x for one day, right? Now is it clear how y is equal to 25x?
Yeah.
Okay, so we have got this relation. Now we just have to find the variance of x. Okay, so we can use this property. Now we have to find the variance of x. Okay, so, variance of y will be equal to variance of 25x, which will be equal to what? 25 square variance of x. Okay, so 25 square, which is 625 multiplied by variance of x is 25. Okay, so now it will be equal to 15,625. Now is it clear? Any doubt in this question?
Can you explain the last part again?
Okay, how y is equal to 25x, this thing.
Yeah.
Okay, so see what is the random variable x. Okay, first of all, look at the question, what it is saying, what things are given in the question. So what is given to us? The variance of number of tickets sold in one day in an opera theater. Okay, so now we have to suppose some random variable for which the variance is given to us, which is 25. So now I'm assuming that we have some random variable x, which is what? Number of tickets sold in a day in an opera theater. And this is for one day, right? Sold in a day in opera theater. So this variance is given to us. Variance of x will be equal to 25. Now in the second line, what we are given for each ticket, okay, for each ticket sold, profit is 25, right? So if we have to find the total profit that we have obtained in one day, so what we have to do? 25 for one ticket. So we will multiply the number of tickets into the profit on one ticket, right?
Yes.
Okay. For one ticket,
Yeah, I
for
got it.
one ticket, okay, profit is equal to 25. Okay, so for x number of tickets, okay, x is representing what? Number of tickets sold in one day. Okay, so
Yeah.
for x ticket, profit will be 25 times x.
Okay,
Okay,
okay, got it, got it.
so for which we have to find variance. Variance of what? Profit obtained in one day. Okay, so here I am taking another variable, which is y. So which is representing the profit obtained in one day. Okay, so we have to find the variance of this random variable y. So here we can see that y will be equal to 25x. So that y is what? Profit obtained in one day. Okay, so that will be equal to 25x. Okay, now I have just used this property. Okay,
Right. Yeah.
okay. So by using this property, this will be equal to this. Okay, now is it clear?
Yes, yes, clear.
Okay. Now the next question is, among the random variables x, y, and z, y is equal to 2x, and x and z are independent. Okay, so random variable x and z only are
Excuse
independent.
me. Yeah, just
Uh,
wanted to ask you one thing. Yeah, in the
hmm,
previous question, can we do one thing like just I don't know if I'm right or wrong, because the thing is that now we know that in a day like total profit earned is 625 rupees in a day basically. So 25 into 25, right? So if I want to find that variance basically of 625, and I know that by the normal formula it's like 1 by n and summation xi minus x bar whole square, whatever the formula is basically.
hmm.
So with the help of that formula also we can do it, right? Because in that case also it will come 625 whole square by 25.
But the
Just
profit
asking.
is not six. Profit is not 25. Now it is the variance of profit 25. Number of tickets sold is not 25. It is variance of tickets sold.
No, 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 no. See, number of tickets sold in a day is 25 in the first line.
Right.
So basically
Not
25 is the number of tickets
it
which
is
can come down.
variance of number of tickets sold.
So yeah, number of tickets is not 25.
Okay, okay. Sorry, sorry.
Okay, this
Correct,
is
correct.
the variance for number of
In
tickets.
some number.
Okay,
Okay,
and profit is also 25 here. Like figures given are same, so don't confuse with that.
okay, okay. Okay.
Okay,
Thank you, thank you.
so it's not number of tickets, it's variance for number of tickets. Okay, then profit for each ticket.
Okay, okay. Got it, got it. My bad. I didn't see that.
Hmm.
And I'm sorry for interrupting. Could you
Hmm.
share the YouTube link for this class?
This what?
Could you
The
share the
recording link.
YouTube link?
YouTube link. Okay, 1 minute.
And ma'am, I didn't attend the first session that was conducted. Do we have the recording for that? The statistics first session?
Recording for that. I think it should be there on YouTube.
I'll share. I'll share.
Oh, okay, thank
Okay.
you.
Okay, I have sent the YouTube link. Okay. Okay. Then your next question. Question number 9. So among the random variables x, y, and z, so y is given equal to 2x. Okay. And x and z are independent. So variance of x is equal to 2, variance of z is equal to 7. We have to find this value, standard deviation of x plus y plus z. Okay, try to solve it. And notice one thing here that only x and z are independent here, okay? Not all three.
See, is it root 17?
The answer is 5. So in this question, you should keep this thing in mind that only x and z are independent. Okay, not all x, y, and z are independent.
It's 5, right?
Yeah, it's 5.
Okay.
Okay, now let me also solve this question. So what we have to find? We have to find standard deviation of x plus y plus z. Okay, so simply I can write it like this. Square root of variance. Square root of variance of x plus y plus z, right? Now variance of x and y is equal to what? 2x. Okay, so 2x plus z. Now again I can write variance of 3x plus z, right? Now if you look at that this property again, which I have showed you here. Okay, so if you multiply some constant, it becomes like this: square times square of that constant times variance of your original variable. Okay, and if you add something, then it will not affect your variance. So here we are multiplying 3. 3 is multiplied with x. Okay, so it will be 3 square. So I can write it like this: variance of 9 times variance of x, right? Plus variance of z. Okay, and again one more property which we have to use here. So if you are given, suppose 2 random variables or 3 random variable, okay, and all the 3 are independent. Okay, if all the 3 are independent, how I can write it? It will be equal to summation of the variance of individual variables, right? So this property I have used here. Okay, so here you can see that x and z are independent to each other. Okay, so now I can write it like this: that square root of 9 times variance of x plus variance of z. Now I will put the values. So 9 into variance of x is what? 2 plus variance of z is equal to 7. Okay, so that will be equal to 18 plus 7 under root 25, which is equal to 5, right? Is it clear now? And here you should remember that this property we can use only when all the 3 variables are independent to each other. Okay, so x, y, z are independent in that case. Okay, so in the given question you can see that only x and z are independent, not all the x, y, z. So what I have done, I have put the value of x, put the value of y. Okay, and then I have converted, like it came to only x and z variable. Okay, and then put the value. So is it clear? Any doubt in this question? Is it clear now?
Yes, ma'am.
So the next question is, suppose an urn contains marble of 2 different colors, red and yellow. A marble is drawn randomly from the urn and its color has been recorded. Then the marble is kept in the urn. Okay, it like replace it. We have replaced it in the urn and then remixed before the next draw. Suppose the proportion of yellow and red marble in the urn is pi 1 and pi 2. Let the urn has 15 marbles, out of which 6 are red, and a total of 10 marbles is drawn from the urn in the stated manner. So based on the information, You have to answer the question number 10 and 11. Okay, so I'm drawing out of picture here. Suppose this is your urn. Okay, you have marbles of two different colors, red and yellow. And we have total 15 marbles, out of which 6 are red. Okay, so we have 6 red marbles. Okay, so total we have 15, so remaining will be 9. So 9 will be of yellow color, right? And proportion of yellow and red is pi 1 and pi 2. So yellow, proportion for yellow is pi 1 and proportion for red is pi 2. So in this question number 10, you have to find the pi 1 and pi 2. Okay, so pi 1 is what? Proportion of yellow color, and pi 2 is proportion of red color marble. And total we have 15 marbles.
Option B.
Yes, option number B is correct. So how did you find it?
Generally calculate the proportion. 6 divided by 15 and 9 divided by 15.
Yeah, it's very simple.
Yeah.
So total yellow marbles. So pi 1 is for yellow. So yellow marbles are 9 and total 15. So 9 divided by 15, which will that will be equal to 0.6. Okay. And for red marbles, 6 divided by 15, that will be equal to 0.4.
Or another simple way is like pi 1 and pi 2 are like exhaustive. So their sum will be equal to 1.
Yeah.
So option B is the only option.
Yeah, in that way also you can check. Okay, so that should be clear to everyone, I hope. Okay, now the next question is, so in the experiment, find the standard deviation of number of yellow balls drawn.
Can you just move up the question, show the question on the screen?
Yeah. We have to find the standard deviation of number of yellow balls. Okay. Question number 11. So in this question, notice one thing, that the marble is kept in the urn and remixed before the next round. Okay. So we are taking one marble. Okay. Then we are putting back it into the urn, and then we are drawing the second marble. Okay. Now try to figure out what distribution the random variable will be following, and what random variable you should take here in this question. Okay. And then if you are able to find the distribution, you can directly use the formula for variance of that variance of the random variable in that particular distribution.
I mean, the 10 balls are drawn, so that means that in that there can be um, 9 yellows and 1 red. Possibilities are there. I mean, so 9 will be the maximum number of balls yellow drawn. Then it can be 8 yellow and 2 red. And if six are red, then there should be minimum number of yellows to be drawn will be 4. So should be range between 4 and the yellows will be ranging between 4 and 9.
Okay, see, in the question, what we are given, we have to find the standard deviation of number of yellow balls drawn. Okay, and how we are conducting this experiment. So we have some marbles of different two colors. So marble is drawn randomly from the earth. Okay, so we are taking a marble randomly, then we are noting its color. Okay, then what we are doing, the marble is kept in the urn and remixed before the next row. Okay, which means we are putting back the marble, right? And then we are drawing our next one. Like we are doing the with the replacement, not without replacement. Okay. Now what? Let the urn has 15 marbles, out of which 6 are red, and a total of 10 marble is drawn. Okay. So we are drawing 10 marbles. Now if I take a random variable x, which represents the number of yellow balls, okay, since in the question what we are asked, we have to find the standard deviation of number of yellow balls. Okay, so I am taking a random variable x, which represents the number of yellow balls drawn. Okay, now what should be the probability of drawing a yellow ball? Sorry, it's a marble, not a ball. Okay, so probability of drawing a yellow marble. So what will be this probability? So P should be equal to what? So here you can see that you have total 9 yellow marbles out of
Point
15.
six.
So it will be
0.6.
9 by 15, which is equal to 0.6, right? Now, don't you think that X should be following the binomial distribution? Okay. And like, uh, so there are two parameters in binomial distribution, which is what? N and P, right? So P represents what? Probability of success. Okay. And N is what? Total number of trials, right?
Right.
So here you can see that what we are doing, we are taking total 10 marbles. Okay. So you can see that you are performing uh, your experiment 10 times. Okay. You are drawing marbles 10 times. You are noting the color. Okay. And put it back into the urn. So for each So n will be equal to 10 here, right? And p is what? Probability of success. So what is success here? If you're drawing a yellow ball, sorry, not
Point
ball,
0.6.
marble, yellow marble, then it will be your success. So it will be 0.6, right? Is it clear?
Yeah.
Okay, because we are putting back the marble and then we are drawing the next one. Okay, so we are doing it with the replacement and not the without replacement. Now you know what distribution x is following here, so we can directly use the formula. So variance of x, if x is following binomial distribution, it is equal to what? Np 1 minus p, right? Okay. Now if you have to find the standard deviation of x, that should be square root of np 1 minus p. So n is what? N is 10, p is 0.6, okay, into 1 minus 0.6, which is 0.4. Okay. Now find out this value. That should be equal to this 1.549. Check whether this value is equal to 1.549 or not.
So this is sort of that Bernoulli thing, right?
Yeah, so it is kind of Bernoulli trial. Okay, so here you can see that you are performing your trial 10 times. Okay, and what is your experiment or trial? So you are taking one marble from the urn, okay, and you are noting its color. Okay, like if it is yellow, then this is your success, and if it is not a yellow color, if it is a red color marble, then that will be a failure for you.
So it is not. So we are not putting it back in the urn or the marble back in the urn, or
Yeah, we are not putting it back.
okay.
Okay, in this line you can see it. The marble is kept in the urn. Okay,
It is remixed,
remixed.
right?
Okay, and then we are
So we
drawing
are
the
putting it
second
back
one.
only, right?
What?
We are putting the marble back in the urn, basically.
Yes.
Then only the proportion will stay same, right?
Yeah.
Okay. Okay.
Okay. So then you can see that for each trial, the probability of success will be same, which will be 9. Sorry, 9 by 15. Okay, because for each trial, you are having 9 yellow balls.
Okay. Okay.
Okay.
Understood. So
So
basically, in the formula, it gets multiplied with the number of trials.
yes. So Bernoulli, in case of Bernoulli, what is your, if X is following Bernoulli with probability of success P, then what is your mean? So mean or the expectation of X is what? P, and variance of X is what? P 1 minus P. Okay, and if you are, and Bernoulli and binomial, how they are related? Like if you are doing Bernoulli, like if you are performing the same experiment n number of times, okay, so then it becomes binomial. Okay, so binomial is nothing but the summation of the Bernoulli trials. Okay, so if you are performing your trial n times, so it becomes binomial n comma p. So in that case, expectation of x becomes np, and the variance of x becomes n times p 1 minus p. Okay,
Okay.
so here you can see that we are doing an experiment 10 times. Okay, taking a marble, noting its color. If it's yellow, then it's success for us. If it is not yellow, then it is failure for us. Okay. The two things we have to know for binomial distribution, N and P. So that we already know here, right? So we know the distribution of X. So we can directly use the formula for variance or standard deviation. Now is it clear? Any doubt in this question? So you have to identify what distribution X is following here, right? So you can see that because we are not putting back the marble, okay, so probability of success is not changing. And you can see that we are performing the trial for n number of times and it is a Bernoulli trial. Okay, so in that way, you can understand that here the random variable will be following the binomial distribution. Any doubt in this question? Or we can move on to the next one. So the question number 12 is, in a software office, there are 20 junior developers, of which 8 are men and 12 are women. So if 5 junior developers are to be promoted to senior level, what is the expected number of women in the promoted developers? Okay, now take some time, think about this question, what we are doing and what distribution of x should be.
Is it 0.24? 3?
Yeah, it is coming 3.
Okay, so how did you identify?
So basically, we have to find the expected number. So
Hmm.
n into p you can do to find that. So p is basically 12 by 20, which is 0.6 into n 5.
Okay, yeah, in that way also you can do. Okay, else if you try to see. So what question says, in a software office, there are 20 junior developers, of which 8 are men, 12 are women. Okay, suppose. So 8 are men, 12 are women. Okay, and total is 20. Okay, now 5 junior developers are to be promoted to senior level. Then we have to find what is the expected number of women in the promoted developers. Okay, so like we have these 20 candidates. Okay, and we are taking a sample of 5, right? And we have to see that in the sample, okay, in that 5 junior developers that to be promoted to senior level, what is the expected number of women, okay, that is to be promoted. So like it is the case for hypergeometric distribution. Okay,
So we can do 5 by 20 is the into point into 12, right? Basically, 5
yeah,
since 5.
expected value is the same. Okay, so what
Yeah.
happens in case of hyper geometric distribution? So in hypergeometric distribution, what we do, we have our entire population. Suppose capital N number of observations are there in your population. Okay, And also remember that this is the case for discrete variable, like hypergeometric distribution is for discrete case. Okay, so in that case, your random variable will be discrete and not continuous. In binomial also, that is a distribution for a discrete random variable. Okay, so like in the question you were saying that your answer was 0.24. Okay, and like the question
Actually,
is
no,
what?
no, I did a mistake in that one. I
Yeah,
have
yeah, yeah.
rectified.
That is okay. Okay, but like I'm telling you, like you can check that whether your answer 2.24 should be correct or not. The expected number of women should not be in decimal, right?
Right. Actually, I followed the Bernoulli thing in this one. Like
Hmm.
selection of the woman is a success, but I forgot to. Yeah, I'm
Okay,
sorry.
no problem. Okay, so suppose we have what we do in hypergeometric distribution, we divide the whole population into two parts, like two categories. You can say two categories will be there. Suppose one is m number, like for category number one, you have now m number of observations. As in this case, you can see that we have divided our population into male and female, men and women. Okay, so 8 number of men and 12 number of women are there. Okay, suppose I'm representing this is like for category 1, you can say that number of observation is m, so the remaining will be capital N minus m. Okay, and that depends on your objective. You can take like this is suppose 1, this is 2, so you can say that m number of observation in this category and n minus m in this category. Okay, so that depends on your objective. Okay, so that will not affect. Now what we do, we take a sample from the entire population. Okay, so it will contain all the two categories, right? So suppose I'm taking the sample of n observation, okay, which contains both two categories. Okay, so now we have to find out the expected number for category 1 or 2. Okay, so in this question also you can see that total population is of 20 candidates. Okay, 20 developers are there, in which 8 are male, 12 are female. Okay, out of which we are taking a sample of 5. Okay, so now what we do, we are taking a random variable x, okay, which will represent the number of women. Okay, so in that case, m is equal to 12 here. In that case, I'm taking m is like number of women. Okay, now what we have to find? We have to find the expected number of women in the promoted developers. We have to find the expectation of x. So that is, if you remember the formula, that is what? N m by capital N. So n is what? Sample, okay, which is equal to 5. M is what? Total number of women in the population, which is 12. And capital N is what? Total number of, like your total population. So that will be equal to 20. Okay. So from here you can see that will be equal to 3. So in the similar way, if you have to find the expected number of men, okay, then you can take another random variable y, okay, which will be representing the number of men. Okay. So the expectation of y is equal to what? N m divided by capital N. Okay. So now suppose if you are taking, in that case, I am representing m is equal to, like by m I am representing the number of men in that case. Okay, so it will be like n is 5 again, m will be equal to 8, and total population is 20. Okay, so in this way we take a random variable and decide the value of m n and capital N. Okay, is it clear now?
Yes, yes.
So now the next question is, a car hire firm has two cars. Okay, one more thing I would say in for hypergeometric distribution. So in that case, the probability of success changes from trial to trial. Okay, and we are taking the things without replacing them. Okay, so in case of binomial distribution, what happens? We are doing a trial or experiment with replacing. Okay, so in that question, in the previous question, we were replacing our marbles and then putting the next one, right? But in case of hypergeometric, we do not replace our items. Okay, we select the items without replacing them. Okay, and that's what that is why the probability of success changes for each trial. Okay, so like this is the key difference in binomial distribution and hypergeometric distribution. Now the next question is, a car hire firm has two cars which it hires out day by day. The number of demands for a car on each day is distributed as Poisson distribution with mean 1.5. Now calculate the proportion of days on which neither car is used. Okay, so here we are given that a random variable, suppose it is x, and it is following Poisson distribution, and mean is given. So you have to calculate this proportion or probability. Okay, try to solve it. Check whether your answer is equal to 0.223 or not.
What is Poisson distribution?
Okay, so Poisson distribution basically tells you about the number of times an event occurs in a particular time interval or a space. Okay, so suppose you have a random variable x which is following some Poisson distribution. Okay, so Poisson distribution has one parameter which is lambda, and for Poisson distribution the expectation, okay, the average is also lambda, and the variance of x is also lambda. Okay, so what x represent here? X represents the number of times an event occurs in a particular time interval or space. So for example, uh, you are saying like number of customers arriving to your shop. Okay, so in that case, how we represent lambda? Lambda is the average, right? Expectation. So that will be the average number of customers arriving in a time interval of 1 hour. Okay, so time interval varies. Like suppose you are taking in like number of customers reaching per 10 minutes, or number of customers arriving in 1 hour, or number of customers arriving in 2 hours. Okay, so in that way we define our time intervals. And what does space mean here? So like if your interval is not a time interval, suppose you are calculating, you are taking your random variable as the number of mistakes you have done, number of spelling mistakes you have done in one page. Okay, suppose you have one page, you have written something. Okay, so you are counting the number of spelling mistakes. So in that case your space is one page, or you can take the number of spelling mistakes in 5 pages, so that 5 pages will be your space. Okay, here we are not talking about the time, so like we say it as a space. Okay, so in this way you can take different examples. So number of times that event occurs, that is represented by the Persian random variable. Okay, and lambda is what? So this is the one only parameter in Poisson distribution, and it tells you the average value. Okay, so in the second example, it will be the average number of mistakes you make per page. Now is it clear?
Yeah.
Okay, so in this question, what is given? A car hire firm has two cars. Okay, so which it hires out day by day. The number of demands for a car on each day is distributed as Poisson distribution with mean 1.5. Okay, so x will be what? Number of demands for a car on each day, right? Right.
Yes.
So X is what? Number of demand for a car on each day. Okay, now X is following Poisson distribution with mean is equal to 1.5. And we know that lambda, that parameter, is nothing but the mean. So that is given to us 1.5. Okay, now lambda represent, in this case, what will be lambda? Average demand for a car on each day.
1.5.
Okay, so what we have to calculate, proportion of days on which neither car is used. So neither car is used, which means the demand should be equal to 0, right? Okay, when the demand is 0, then no car will be used. So we have to find probability of that X is equal to 0. The proportion gives you the probability, right? So we have to find probability X is equal to 0. Now you can use the PMF for Poisson distribution. So what is the PMF if X is following Poisson distribution? Anyone?
E power minus lambda, lambda power x, all
Divided
divided
by
by
X
x
factorial,
factor. X
right?
equal to 2 factor.
So in this PMF, you just have to put the value of X is equal to 0 and value of lambda is also given. Okay, so that will be e to the power minus lambda, so which is 1.5, lambda to the power x, which is 1.5 to the power 0 divided by 0 factorial. Okay, so that will be equal to e to the power minus 1.5, and e to the power minus 1.5 is equal to 0.223. Okay, now is it clear? Now, do you all understand what is Poisson distribution? Any doubt in that? So X representing what? Number of events, number of times an event occurs in a time, in a time interval or space. Okay. So in binomial distribution, what does X represent? Like if X is following Poisson distribution, then it is representing the number of times that event occurs in a time interval. So similarly, what does X represent if X is binomial distribution?
Successor failure.
Number of success,
Number of systems.
right? Number of success in n trials. Okay. So if we are doing our experiment n number of times, we are having n trials. So total number of success in all those n trials. Okay. So is it clear now? Now the next question. And Poisson distribution is also a distribution for discrete random variable only. Okay, it is not for continuous. It is for discrete. Okay, so here x, the range of x will be like from 0, 1, 2, 3 up to so on, up to infinity. Okay, now the next question, question number 14. The lifetime of a light bulb is exponentially distributed with a mean life of 18 months. If there is 60% chance that a light bulb will last at most t months, what is the value of t? So here, what we have to study, like we have to study about the exponential distribution. Okay. So if x is following exponential distribution, okay, so it also has a parameter which is represented by lambda. Okay, so if x is following exponential distribution with parameter lambda, then in that case expectation of x will be equal to what, and variance of
Lambda,
x,
lambda square.
lambda.
Yeah, expectation lambda.
So expectation will be 1 by lambda and not lambda. Okay,
1
and
by lambda.
variance will be 1 by lambda square. Okay, in case of Poisson distribution, okay, the parameter is mean. Okay, so in that case expectation is lambda, but in exponential distribution, like it is the inverse of parameter. The expectation is inverse of the parameter. Okay, now try to see what is given in the question and how can you find the value of t here. Yeah, have you tried it? So in this question, the lifetime of a bulb is exponentially distributed with a mean life of 18 months. So what is given to us? Mean is given to us 18 months. So expectation of x is 18 months. Okay. So that should be equal to 1 by lambda, right? Okay. So from here we can find the value of lambda. So lambda will be equal to 1 by 18, right? So now I can write that x is following exponential distribution with parameter 1 by 18, right? Okay.
Right.
Now what is given if like it is asked that when if there is 60% chance that a light bulb will last at most 3 months, then what is the value of t? Okay, so like 60% chance is there, so in probabilities, in terms of probability, I can write it like 0.06, right? So the 60%
Yes.
chance is there that light bulb will last at most t months, like maximum limit is given to us. Okay, so x should be less than or equal to t, right? Like maximum it can take, it can last up to t months. So x should be less than or equal to t. This probability is given to us as 60%. Okay, this has 60% chance, so that will be equal to 0.6. Now by using the CDF, Okay. If you remember the formula for CTF in case of exponential distribution, you can directly use that formula. Or if you don't remember, then you will have to do some integration. Okay, and then you can find this probability. Okay, so if x is following exponential distribution with parameter lambda, then in that case, CTF at some point a is equal to what? 1 minus e to the power minus lambda e. Okay, so this is the CTF for exponential distribution. Okay, and if you don't remember, then how will you solve it? You will have to integrate it from lower limit up to t. So the maximum limit will be t. Okay, and the lower limit for exponential distribution is, like in that case, x is greater than 0. Okay, the range of x is greater than 0. So the lower limit will be 0. So from 0 to t, you will have to integrate the PDF. Okay, that will be equal to 0.6. So either you can use this method or you can directly use the formula. So here I am using the direct formula. Okay, so
What is
probability.
this formula, if you don't mind explaining once again? This FA equal to 1 minus.
Yeah, so like this is the CDF. Okay, if you solve, the CDF will be equal to this. If you solve this integral, so the CDF is equal to 1 minus e to the power minus lambda n. Okay, so what do you have to do? Okay,
So this is
so what is the
specifically for exponential function, right? The CDF
mm,
for exponential function.
yeah, it contains exponential term.
Okay.
Okay, and what is the PMF? So if x is following exponential distribution with parameter lambda, then what is the PMF? Sorry, not PMF, PDF. Because exponential distribution is for what? Continuous random variable. Okay, and for continuous random variable, we study PDF, probability density function. Okay, and if your random variable is discrete, then what is then we study probability mass function. So here
P
your PDF, okay, is equal to lambda e to the power minus lambda x. Okay, and x is taking values greater than 0, and lambda should also be greater than 0. Okay, so if you integrate this thing, lambda e to the power minus lambda x, okay, over the range. So suppose if you have to find over a point a, okay, like in that case. Okay, so from lower limit to a, you will integrate this thing. Okay, and you will get this formula as 1 minus e to the power minus lambda a. Okay, so here I am directly using the formula. So that will be 1 minus e to the power minus lambda. So lambda is what? 1 by 18. So minus 1 by 18. Okay, into you have to find at point t, right? CDF at point t we have to find. So in place of a, I will write t. Okay, so 1 by 18 into t. That should be equal to 0.6. So 1 minus e to the power minus t by 18, that is equal to 0.6, which implies that e to the power minus t by 18, that should be equal to what? 0.4, right? 0.4, not 0.14. Is it clear till this point? Okay. So if you further solve it, so I can write it like this also, 1 upon e to the power t by 18, right? Okay. Now I can write e to the power t by 18 equal to 1 upon 0.4, right? So e to the power t by 18 will be equal to 0.25, 2.5, sorry. Okay. Now if I take log at both sides, that will be what? Equal to what? T by 18 equal to log 2.5, right? Is it clear? This will be log 2.5. So from here, t will be equal to 18 times log 2.5. Is it clear now? Any doubt? Any doubt in this question? So what we have to do here, so this thing we are given, right? That probability x is less than or equal to less than or equal to t is equal to 0.6. And this is what? If you know what is CDF, so CDF is what? That probability fx is equal to, right?
Yes. Yes.
Okay. So we have to use the formula for CDF. So either you can integrate if you don't remember the formula, or you can directly put the values into the formula, right? So the value of t, like at point t, we have to find CDF. Okay. So it will be 1 minus e to the power minus lambda t. And value of lambda we have find out. Okay. So in that way, we will solve. So value of t will be equal to 80 log 2.5. Okay, any doubt? Or we can move to the next question. Okay, so the next question. So this is also the last question. Yeah, this is the last question also. The traveling duration of time taken every day by a train is uniformly distributed between 200 to 220 minutes. What is the probability that the duration of the time taken is more than 215 minutes, given that on that day, more than 210 minutes of the time was taken? Okay, now first try to figure out what is given to us, okay, and what we have to find in this question. Okay, so in this question, what is given? That traveling duration of time taken every day by a train is uniformly distributed, okay, between this range 200 to 220 minutes. Okay, so suppose we have a random variable x which is uniformly distributed, okay, between 200 to 220, right? So what is the probability that the duration of time taken is more than 215 minutes, given that on the day more than 210 minutes of time was taken? Okay, let's first understand what is uniform distribution. Okay, so if x is following uniform distribution with parameter a and b, okay, which means that x is taking values in a to b, like in this interval x is taking values, okay, and for each point the density will be same, and what it is, 1 upon b minus a. Okay, so this is the PDF for continuous uniform distribution. Okay, So here in this case, you can see that X is a continuous distribution and not discrete. Okay, so X is taking values from A to B. So the density function is 1 upon B minus A. Okay, so if you find for this, so in this case, Fx will be equal to 1 upon 220 minus 200, okay, which is equal to 1 upon 20, right? Now what we have to find? More than 215 minutes, okay, probability that X is greater than 215, okay, given that on the day more than 210 minutes of time was taken, given that X is greater than 210. So this probability we have to find. Okay, now we can see that this is a case for conditional probability, right? So what should be it equal to?
We take the intersection.
Yeah, so we take intersection of both. So X should be greater than 215, intersection X is greater than 210, divided by probability that X should be greater than 210 or 215.
210.
210, right?
Yeah.
Okay, like what is the formula? Probability A given B, it is equal to what? Probability A intersection B divided by the probability of B, right? Okay, so now you can see, so suppose this is our line, this is 210, this is 215. Okay, so 215, this part and this part, greater than 210 and greater than 215. So what will be the intersection part for these two? What should I write?
Point five of
Like I can write it as X is greater than 215. Okay,
right.
like this is the intersection part. Okay, so I can write probability X is greater than 215 divided by probability X is greater than 210. Now again here you can use the CDF thing. Okay, so I can write it like this also, 1 minus probability X is less than or equal to 215 divided by 1 minus probability X is less than or equal to 210, right? Now what these two terms represent? So this is nothing but the CDF, right? At point 215 and 210. Okay. Now if you remember the formula for CDF, you can directly use that or you can integrate it. Okay. Now if you remember, if X is following uniform distribution uh, with parameter A comma B, then in that case the CDF is equal to X minus A divided by B minus A. Okay. Uh, in this way, right? When X is less than 0, less than A, that will be 0. Okay. And if X is greater than or equal to B, that should be equal to 1. Okay. So in this way, we calculate the CDF, cumulative distribution function. So if I use the formula, okay, so X minus A divided by B minus A. So X is what? Like the point at which we have to find the CDF. Okay. So here we have to find the CDF at point 215. So 215 minus A. A is what? The lower limit. Okay. So which is 200 here. Okay. And B is what? This is A and this is B. So A is 200 and B is 220. Okay. So 200 divided by 220 minus 200. Okay. This is divided by 1 minus now CDF at point 210. So 210 minus A is equal to 200 divided by B minus A, which is 220 minus 200. Okay. Now if you solve it, so that should be 1 minus 15 divided by 20, right? Divided by 1 minus 10 divided by 20. So if you further solve it, that will be 20 minus 15, which is 5 divided by 10, so which is equal to 0.5. Okay. So 0.5 is the answer. Is it clear to everyone? Also, okay, let me show you the another method also. If you don't remember this CDF formula, okay, now what we have to do till this point, the procedure is same. At this point, I have used the formula. Okay, so what we have to find 1 minus probability. Okay, you can directly solve from here also, right? So what we have to find? We have to find the probability that x is greater than 215 divided by probability x is greater than 210. Okay. Okay, now if you have to solve this probability x is greater than 215, how will you solve it? Don't use any formula like the formula of CDF. You don't have to use. How will you find it?
Through integration.
Yeah, through integration. So integrating what? The PDF. Okay. Now, what should be the limits for the integral?
Upper limit
215
will
to
be
lower
230.
limit 220, 215 to 220.
From 215 because x is greater than 215, right? So the lower limit is given. Lower limit will be 250. Okay. Now from the distribution of x, we can see that the maximum limit that it is taking is 220, right? So the maximum will be 220 from 215 to 220. Okay, fx dx. Now what is fx? We have, okay, so this is your PDF for this uniform distribution. So this is 1 by 20. Okay, so in place of fx, I can write 1 by 20. Okay, so this is 1 by 20. Now for the denominator part, it will be from 210 to 220, right? Again, fx into dx. Fx is what? 120, 1 divided by 20. Now we have to solve these two integrals. Okay, so I can take 1 by 20 as common. It will be x from 215 to 220. So this is also x from 210 to 220. Okay, so this 1 by 20 will be cancelled out. So that will be 220 minus 215 divided by 220 minus 210. Okay, so that will be 5 divided by 10, which is equal to 0.5, right? So if you don't remember the formulas, you can use the integration method also. Now is it clear? So if you have any question, any doubt, you can ask. So this was the last question. If you want to ask any question from this, you can ask. Any doubt? So if you don't have any doubt, then we can end the session.
Hello,
Or if you
madam.
want to ask something, yes.
Madam, actually, how is the exam pattern of the statistics paper like?
For this DAT qualifier.
Yeah, this data and this exam. Qualifier exam.
So for like direct admission to diploma, you for statistics one, I can tell you. So like From all the weeks, you will be getting the questions.
Okay.
Okay, from week 1 to 12.
Okay,
So
like
in
in
this,
the first introductory modules, all like every portions there will can be the questions. Like
yeah, from week 1 to 12. In introduction part, like it was nothing but the introduction, right? Like from week 1 to 12.
okay,
Yeah, so in your DAT qualifier exam for statistics 1, you will be getting the questions from all the topics.
madam, the number of total marks is 50 for this statistical paper.
Mm, that I don't remember at this point. Like, what is the total marks?
Oh, this is the PYQ question, like last year question. This paper what you have solved is the previous year question.
Uh, some of the previous year question and some of from like based on the topics that are covered from week 1 to 12.
Okay, ma'am. Thank you.
One question here is that for every question, whether the relevant marks will be marked against each and every question, so that we can at least get some idea about how much we'll score for every question if it is right.
Yeah, marks will be written alongside with
Okay.
the question.
Yeah, so it will not be equally distributed for all the questions, no?
Yes.
There was one question also in the chat actually about negative marking. There is no negative marking, right?
Yeah, I don't think there is negative marking.
Okay.
Yeah, so I have sent the link again. Someone was asking about the link of today's class. Okay, so I have sent the link in the chat box. Yeah, any other question or we can end the session? Do you have any other doubt? Okay, then thank you everyone for joining. All the best for your exam.
Thank you, madam.
Thank you.
Thank you.